Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to be discussing with you guys generic methods and generic classes in Java, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright guys, let's talk about generics. So, the definition for this is that generics enable types, which are classes and interfaces, to be parameters when defining classes, interfaces, and methods. So, a benefit of this is that it eliminates the need to create multiple versions of methods or classes for various data types. So basically, we can use one version of a method or a class for all reference data types. So let me give you an example. So here's an example for you guys. I have 4 different arrays here. They all have different data types, and please note that these are reference data types. So we have an array of integers, doubles, characters, and strings. So we're using the wrapper class for some of these primitive values, such as like integer, double, and character. So what if we wanted to display all of the elements in each of these arrays? So normally what we would have to do is to create a method that can handle all of these individual different data types. So let's say, for example, we have a method called display array, and this accepts an integer array. So this is only compatible with our array of integers that, for our example, we just called int array. Now, if we wanted a similar method for doubles, characters, and strings, we would have to create another method that can handle each of these different data types that we have. So we'll create another array. This one will accept doubles. So replace integer with double. And let's do the same thing for character and string. So character, character, and then string. And then let's just test this. So we're going to call the display array method, and let's send in our integer array. Then we're going to do the same thing for double array, character array, and string. And let's run this. So yes, this does work, but it's kind of inconvenient to have 4 separate methods when they basically do the same thing. So here's a crazy idea. How about we don't? Let's create one version of this method that can handle all reference data types. So let's delete 3 out of these 4 methods that we painstakingly created, because we only are going to need one, really. So in order to use generics, we're going to be discussing both generic methods and then generic classes. So in order to use a generic method, right before the return type, we're going to add a set of angle brackets. And then typically, if people want to use generics, the common thing to do is just to place the letter T within here. That's just common practice, but I like to type in thing just because it helps me remember that this is a generic. So this is now a generic method. However, we can still only pass in an array of integers. So with the data type, we're going to replace that with whatever value or text is within these angle brackets. So we're going to accept an array of things, and then we're going to replace integer here as well with thing, or whatever value you placed here. And remember, it's usually T that people write here. That's just my quirk where I like to write thing, just because it helps me remember this. And if we were to run this, this does the exact same process as what we had previously before we used the generic method. So this is I would say, a shorthand or more efficient way to write your code, because you don't necessarily need an individual method for each individual data type that you have. You can just have one version that will accept all reference data types. Although you do have the capability of limiting the data types that are entering into a generic method or class by a concept called bounded parameters, but we'll discuss that later on in this video. So let's create another generic method, but this time it's also going to return something that's generic. So it's going to be a similar process to what we have set up previously with this generic method. So we're going to type in public, static, and then this is going to be a generic method. So we're going to type in a set of angle brackets, and then people usually write T here, but I like to write thing, but you do you, I guess. And then with the return type, this cannot be void because we're returning something. So we're going to be returning a thing, or whatever text you have within these angle brackets. And then let's name this method. Let's return the first element within each of these arrays. So let's call this get first, for get first element, I guess. And then we're going to pass in an array of things. So what we're going to be returning is return our array that we receive with this parameter at index 0, so it's the first element. And then let's run this. So I'm going to turn these into a comment for now. So we will system.out.println for each of these. And then we're going to call the get first method within the println statement. So get first, and we're going to pass in our different arrays that we have. So get first int array, double array, character array, and string array. And as you can see, this works just fine. Here's a more practical scenario. So figuratively speaking, let's say that we're creating a video game and we have various game sprites that we want to draw on the screen. We have a player, an enemy, an item, and a tree, and we want to display or draw these all within our game. So this really isn't set up. You can see that I've yet to create these classes, but this will work just for our scenario. So instead of creating a draw method that can only draw players, another draw method that can only draw enemies, another for items and trees, so on and so forth, what we would like is just a generic method. It will accept a reference data type or a thing and just draw it. So you could just have one method that will accept all data types, because we really don't want to have an individual method for all of these separate data types. We want just one method that will take care of everything for us. So that's the real benefit of generic methods. Let's move on to generic classes. Okay guys, let's discuss generic classes. So for this example, I have a few instances of some classes that we're going to create in just a moment. And each of these classes is going to store a different value, and these all have different data types. So my int will store an integer, and we're just going to pass in 1 to the constructor. My double will pass in maybe 3.14, character, the @ symbol, and then my string will just pass in the word hello. So let's create these actual classes, and then we're going to create a generic class just to compare and contrast the differences between them. So let's create my integer class first. So file, new class, we'll call this my integer class. And all this is going to do is store a single integer value, and we'll call it x. And let's create the constructor for this class. So my integer class, and we're going to receive one argument, and that is going to be the value integer x. And we're going to assign this x equals whatever x that we receive. And then let's create a getter method. So public, and we're not going to type in void, we're going to return an integer. Public integer get value. And we're going to return x. Then let's do the same thing for double, character, and string. So I'm just going to fast forward the video at this point. Alright, well, welcome back. So we have 4 different classes, one for my integer class, my double class, my character class, and my string class, and they all will hold one value of each of their respective types. Now let's say that we want to display all of these values, so we're going to use the first myInt.getValue function, and then let's put this within a println statement, so system.out.println, and then within the parentheses of this println statement, myInt.getValue, And let's do the same thing for my double, my character, and my string. So my double, my character, and my string. So this will display all of the values that we have that we sent to the constructor for each of their respective classes. Now let's do the same thing again, but this time instead of creating 4 different classes, we're going to create one generic class that can hold all of these different data types. So I'm actually going to delete all of these. I know it was a lot of work to actually build these, but hey, it's for the video. So let's get rid of these. And this time we're going to create a generic class that will function much the same. So file, new class. We'll call this my generic class. Finish. So to make a class generic, after the class name, we're going to add the angle brackets, and then people usually write T within here, but I like to write thing like I've mentioned before. So now this is a generic class. So now instead of specifying a specific data type that we want to store, we're going to store a thing. So we have a variable that has a thing data type. And then let's create the constructor for this class. So my generic class. And the parameter is that it's going to accept a thing called x. And this x equals x. Then let's work on the getter method for this, and this was public thing, because we're returning a thing, and it is called, I already forgot, get value. Get value. Return x. And now what we're going to need to do is change integer, double, character, and string all to generic to match my generic class. So let's just fast forward through this. So these should all say my generic class now. And you can see that these are all underlined, and let's take a look. So it says that there's a warning here that the constructor my generic class belongs to raw type my generic class. References to generic type my generic class, then it has the angle brackets with our thing, should be parameterized. So what this is telling us is that after these class definitions, we should add the angle brackets and then list the data type of what we're sending to my generic class. So with this number, this integer 1, we should list that we're sending this class, my generic class, an integer. And we're going to do the same thing with double, character, and string. So double, character, and string. And then just to get rid of this warning, we're going to add a empty set of angle brackets after this part of the definition. Alright, so this will work the same as it has before, where all of these values are displaying, and we only had to do this with one class, one generic class. So with these instances of our generic class, you may have noticed that these are very similar to what we do to declare and instantiate an array list. So just as a refresher, we create an array list by typing in array list, then a set of angle brackets, and the data type of what we're storing within this array list, and this has to be a reference data type. So let's store an array list of strings, and this will be called my friends, and this will currently be empty. So my friends equals new array list angle brackets parentheses, and then we just need to import this. So you can see that the way that we instantiated this array list is very similar to what we did to create instances of our generic class. We list the class name, the data type within angle brackets of what we're storing. We need a name equals new, then the data type again. And then let's take a look at array list. So here's the class definition for our array list, and after the class name, you can see that we have the parameter for our generic class, the angle brackets, and for this one it just says E, but it really doesn't matter what you type within the angle brackets. So that's why with array lists, they're using a generic class, so we can store different reference data types. So we can store strings, integers, or even objects. It really doesn't matter. since this is a generic class, we don't need to find a specific array list that can hold a singular data type. Like, for example, we don't need to find a particular array list that holds integers. Then if we want to store doubles, we don't need a different array list. This array list is a generic class, so we can store whatever reference data type that we want within it. We just have to declare what we're going to store within it. So one thing you should be aware of is that sometimes with generic classes, there can be multiple parameters. So for example, between the angle brackets, you might see each value separated with a comma, and the second value is usually named v as a common convention, but I'll just name this thing2 just for learning purposes. So my generic class now has two generic parameters, and we can no longer create instances of this class only by passing in a single value. So we also need to list the second value or the second reference data type that we're sending to these instances when we construct them. So let's say that to create this instance of my generic class, we're going to pass in an integer as well as another integer. And let's pass in maybe two doubles, two characters, and then let's mix up the next one. Let's say we're going to pass in a string as well as a character. So we're going to set up the constructor to accept a thing2 value or reference data type. So thing2, and we'll call this y, and let's set up the constructor. So thing2 will be y. So this y equals y. And let's return y this time. And we're going to change thing to thing2. So now we also need to send in another value of the matching reference data type that we have. So maybe I'll also send in 9, 1.01, maybe the money sign for the character. So for this one, this requires a string and a character. So I need to send in a character this time. So maybe the exclamation point. And then let's run this. So it looks like this worked just fine. We only wanted to return whatever our y value was, and that is the second value that we passed into our constructors for my generic class. So with our generic classes that have two parameters, this is very similar to our lesson on hash maps. So a hash map is a collection of key value pairs, and these accept reference data types. So let's say, for example, we have a hash map of different users for our website. So we can store maybe an integer, this could be the user ID, and their string, which could be their username. So this is very similar to how we created our generic classes that have two generic parameters this time. And let's take a look at our hash map class. So this is going to be very similar to our array list, except here that it has two parameters, k for probably key, and then v for value. But like I said before, it really doesn't matter what you type in here. Like array list had e, and I think that's for elements. But yeah, you can see that hash maps also have two generic parameters. Same thing with how we set up our my generic class. So one last thing I'm going to introduce for this video is the concept of bounded types, and that allows us to limit the scope of reference data types that we can send to a generic class. So my last topic for this video is to discuss bounded types. So this allows you to create objects of a generic class to have data of specified derived types. So for example, let's take numbers. So with my generic class, let's say that we only want to pass in numbers. Integers and doubles are fine, but we don't want to send in any characters, strings, or anything else like that. So what we're going to do after, let's say thing, we're going to have this extends the number class. So we can send in any reference data types, but it has to be a subclass of the number class. So here's a list for you. So here's some documentation for the number class. We have thing extends the number class, so we can pass in any reference data type as long as it's one of these subclasses. And many of these you probably won't recognize, like what the hell is an atomic long? But you can see here that we have the double class, as well as integer, and you probably know of float and long as well, even though we really don't use them too often. Since thing extends number, you can say that the scope of the reference data types that we can pass in are limited to just this list. Any class that is a subclass of the number class. If we had thing extends a different parent class, we would be limited in our scope to a possible different set of subclasses. So that's why with our program, we are limited right now to sending in integers, doubles, and a few other things from that list. Like you can see, we can no longer send in characters and strings for the first value. So if we had thing2 also extends the number class, we need to send in two reference data types that have number as a parent class. So these first two lines would work just fine, but we can no longer send in two characters or a string and a character value. So let's just get rid of these for our example. And then let's get rid of these as well. And then if we were to run this, this will return the second value for our instances of our generic class. So that's pretty much it for this lesson. Hopefully your brain didn't explode from all of the information, and be sure to hit that like button before your brain does explode. So yeah, if you'd like a copy of everything that we've done, I'll post everything in the comments down below. But yeah, that's the basics of generics in Java. Hey you. Yeah, I'm talking to you. If you learned something new, then you can help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro.